Hi girls, so we're going to have a look at, we're continuing on from the number plane that we looked at in the last video. Now we're going to have a look at using rules and tables to plot relationships on the number plane. So first of all, whenever two variables are related, we can use a rule to describe the relationship. We're using the example here of number of kilograms of bananas and cost. So, for example, if bananas are $5 a kilo, then a rule connecting the number of kilos, which we're going to call N, and the cost, which we're going to call C, would be the C equals 5N. The cost equals 5 times the number of kilos that you buy. If we have a rule that's describing a relationship, then we can use that rule to create a table of values, and then the table of values can be used to create a graph. So that's what we're going to do in this short video today. I want to, first of all, just in case there's any question about it, I want to define these two words here, variables and relationship, because they're going to become very important. So you've heard of pronumerals. What's a variable? Well, a variable is just a pronumeral that is able to change. So there's a definition there for a variable, a pronumeral that can change. So in our example here, the number of kilos of bananas that I buy can be different. I could go in and buy 3 kilos, I could go in and buy 4 kilos. Whatever the value of the number of kilos I buy is going to affect the cost. The other word is relationship. In maths, when we talk about a relationship, we're not usually talking about dating. We're talking about how two variables can be affected by each other. So a relationship in the mathematical sense means when one variable changes, the other related variable also changes. So when I change the number of kilos of bananas I buy, it changes the cost. Okay? Let's move on to an example that we did in class. Our example is that there's a relationship between the number of students in our classroom and the number of fingers in our classroom. Now I'm going to assume that every student that comes in the door has 10 fingers. It may or may not be true, but for the sake of simplicity, we'll assume everyone has 10 fingers. So if there's one student in the room, there are automatically 10 fingers in the room. If there's 2 students in the room, we know there's 20 fingers in the room. If there's 3 students, 30, 70, etc. So there is a relationship between the number of students and the number of fingers. If one changes, if the number of students changes, then the number of fingers changes. How can we describe this relationship? There's a rule that describes the relationship between the number of students and the number of fingers, and we've worked it out in class. The number of fingers is 10 times the number of students. For ease, I'm going to use a pronumeral F for the number of fingers and the pronumeral S to represent the number of students. Okay, so that's pretty straightforward. What we can do now is create a table of values. Excuse me. So I'm going to create a table of values. In fact, here's one I've prepared earlier. And I'm going to assign some values for the number of students. So, sorry, just change that from purple to black so it's easier to read. So we'll just go 1, 2, 3, 4. How's that? 2, and 4. And what we're going to get from this table of values is 5 points that we can plot on our number plane. So when there's 0 students in the room, 0 times 10 is 0, so there are 0 fingers in the room. Assuming that there's no fingers lying about in cupboards, but we'll get to that later. If there's 1 student in the room, then there are 10 fingers in the room. 1 times 10 is 10. If there's 2 students, then there's 20. If there's 3 students, then there's 30. If there's 4 students, then there's 40 fingers. So what this does, this table of values, is it gives us a set of points that we can plot. So I can take this point here, 0, 0, and plot it on the number plane. You'll notice that in this number plane here, the x-axis corresponds to the number of students. So really, we could call it the s-axis, couldn't we? The y-axis corresponds to the number of fingers. So let's plot this point here, the point 0, 0. Remember we talked about what 0, 0 was. It's this point, just changed colour. It's this point here called the origin. So make my red dot there. The next point that I can plot is the point 1, 10. So it's 1 on the number of students and it goes up to 10 on the number of fingers. So there it is there. Next point, 2, 20. I go across to 2 on the number of students and up to 20. 3, 30, you get the hang of it. Oh, sorry about that. I really must get an iPad or a touch screen somehow. 330 and the next one's 440. So what do you notice about all of these points? If I wanted to, I could draw a line through them, couldn't I? I'm going to make that line red. So you notice that, it's purple. You notice that I can draw a line through these points here. In fact, that line would go on forever, but I'm quite satisfied with that. And that line describes the relationship between the number of students and the number of fingers. It's a straight line, so we call this a linear relationship. Linear relationship. Alright, what would happen if I introduced a jar of fingers into my room? Say I'm a mad science teacher and I keep in my science room a jar of fingers, and don't ask questions about where I got them from. Just this jar of 5 fingers. Let's say I'm a bit of a Dexter. What would happen then to the rule that would describe the relationship between the number of fingers in the room and the number of students in the room? So let's we'll do the table of values first, and that's going to help us to work out what the rule is. Here's my 5 fingers. They're in the room at every point in time. So when there's 0 students in the room, my jar of 5 fingers is still in the room, so the number of fingers in the room is 5. When there's 1 student in the room, how many fingers are there? Well, there's the 10 fingers from my 1 student and the 5 fingers from my jar, so there's actually 15 fingers in the room. If I had 2 students in the room, how many then? I can hear you all calling out. There's 25, because there's 20 from the students and 5 from the jar. Ugh. and so on. I won't keep going because it's tricky. So let's plot the values and see what it looks like. My first point is the point 0, 5. So it's not going through the origin this time. It's going through this point here. 0. Let me just get rid of those left over. It's going through this point here, 0 on the x-axis and 5 on the y-axis. So it's about halfway between the 0 and the 10. It's really hard to draw points. When I have one student in the room, I have 15 fingers. When I have two students in the room, I have 25 fingers. So you can see, if I kept going, I would continue in that direction. I still have a linear pattern, but what's different about this linear pattern is that it doesn't go through the origin. It doesn't go through that point 0, 0. It actually goes through the point 0, 5. So we've got our line and my very badly drawn points, so it's all wonky. But you get the idea. I've got a new line. I go back to the previous one. It's very similar to this line, except drawn more badly. It's very similar to that line, but it's moved up 5 points. Let's see if we can try to describe the rule that gives us these figures and therefore describes the line. So I'm still timesing every student's timesing every student by 10 to get the number of fingers that the students bring into the room, but I also have to add 5 for the fingers in the jar. So my new rule is going to be it's going to be F, number of fingers, is equal to 10 times the number of students. That's the same as the last rule, but I have to add 5 each time. So here is the rule that describes this line, this relationship. F equals 10s plus 5, where F is the number of fingers and S is the number of students. Okay, I think that's enough for now. What I would like you to do is go back to exercise 4A, and question 4 asks you to set up tables of values using the rules that they give you, and then to plot them on a number plane. So I want you to go and do as many of question 4 in exercise 4A as you can. Hang on, Beth, I'll write that up for you. Exercise 4A, question 4. Now there is they use an expression that you may not be familiar with. I'll just see if I can type it up for you and explain it. They use an expression that looks like this. Negative x is negative 3 is less than x, which is less than 3. If you see an expression like this, actually I think they use less than or equal to and less than or equal to. All that means is that your table of values needs to go from negative 3, so your first value would be negative 3, then negative 2, negative 1, 0, blah blah blah, to positive 3. And on your number plane, you also need to set up your number plane so that it'll have part of the second quadrant going from negative 3 to positive 3. Okay, so I hope that helps. Have fun. Go and do that exercise. Thanks. Bye.